Hello and welcome to video 2 of the Intro to Python in Spyder IDE. In this video, we're going to talk about how to load in an existing dataset into Spyder, obtain descriptive statistics, talk about methods and method chaining, create new variables and recode existing variables, and compare means using an independent samples t-test. So we have everything loaded. I haven't made any changes to where we left off in the last video, but now we're going to go ahead and import the dataset. First, I'm going to show you the dataset here. This is from World Bank. And we can see it's in what's called a wide format. So each row is a country. We see that each country is not on multiple rows, so it's not like a longitudinal data. So it is just cross-sectional wide format. Each column is going to be a variable, and each row is a country. We can see we have a mixture of text as well as floating numbers and integers. And we can see there's a bunch of missings here too. So we're going to go ahead and close this. And now let's go ahead and talk through how we're going to import this in. So we'll be using pandas to import this in. Before we did pandas as PD. So whenever we want to use the pandas, a function from pandas, we do PD dot. So that's why we did a short script here. Because things like scipy.stats or map.lib, it's easier to just use an abbreviation. So we're saying import this, but we can recall it as PLT. It just makes it easier to work with rather than having to write everything out. So from there, we're going to go ahead and say, from the pandas, we're going to use the read CSV function or method, specifically the file name. And we have some encoding. This is because of where we had gotten the data set, so we have to put an encoding thing here. Sometimes if you do it without that, it's not going to read it in right, or it's going to look a little funky. So we're going to store this object, this data frame, as df, which is short for just data frame. And then we can print this out and we can say, okay, we can see a quick abbreviation, the head and the tail of the data set. And if we find the data set here of df, I can click on it and take a look at what it looks like. And that looks like it read in right. Great. So what we can do then too is we can use things like methods. So after importing this, it's really good practice to take a look at the cases to make sure that data was imported correctly. We can use what's called the .head method and .tail method to look at the first couple of cases and then the last couple of cases. The default for head and tail is 5, but we can change that by changing the number and the parentheses. So we're saying we're using the df object or data frame, and we're using .head or the .head method on this. So I'm going to go ahead and run that. It's going to print out the first 5 countries. So you can get a sense of what that looks like. We can also take a look at the last 6 countries. If I change this to, let's say, 2, it'll print out 2 instead. By default, it's going to go ahead and be 5. If we wanted to figure out what the information is, specifically for the data set for each variable, we can run the information method on this for df.info. This is going to tell us information like the column, the position of the variable, how many values we have in it, so not how many non-nulls, and the type of the object, whether it's floating, whether it's a character, and so forth. From there, now that we have a good sense that everything's running correctly, we can do things like we can use methods to select specific variables within the data set by using the command structure of the object or the data frame, square brackets, and then we say, double quotes, the variable name. We can add a dot method. So here we're going to use head on df specifically for just country. And now we have the first 5 from the df of just the variable country. We can do the first 5 for corruption. And look here, we have NaN, that means it's missing. We do the same thing for literacy. Alternatively, what we can then do is we can also save variable names as an object and then port that in rather than the variable name in the square brackets. So we can say all 3 of these, we're saving that as an object because now we have a select, just a list of the variable names, and then df, that list of variables, we want head. So we have head method there, We can say, okay, what are those first five countries with those three specific variables? So that's a really nice way to kind of slice your data and get a sense of what's going on there. We can then also print out frequencies of a variable. So we're going to say df object, I want the free new, and then I'm using the method of value counts, and I'm storing the results as something called free counts. So if I go down here to free counts, a series from pandas, and if I go ahead and print this out, it gives us the counts of how many free, how many partly free, and how many not free. We can then do a quick plot by saying free count dot plot, and the kind is going to be a bar chart. So I'm going to go ahead and move this over here so you can see a little bit better. Let me go ahead and just save this image. And I'll just go ahead and open it here so that way it's just a little bit easier to see. There we go. So now we have our bar chart of how many countries would fall into each of these categories. Oops, don't want to move that. Great. And because I had ran the code by accident previously, so I have some other stuff in there too, but we'll talk about more of that about later. We can also do things like crosstabs for two categorical variables, see look at the relations between those. So I can say from the pandas module, crosstab, and I specifically want OECD membership and DF free new, and I'm going to ask for the margins. So let me go ahead and go to variables, move this up a little bit. So you can see a table where we have whether or not they're an OECD member and the category, and we also have our margin counts here too. We can also do what's called chaining methods. So when we have a chaining method, we have multiple methods in the same line. This is called chaining methods. The command below will pull the variables we have selected in our select list from before. And then, actually, that's going to be a little bit later on down. Yeah, so I adjusted this one a little bit. So we have our free new. So we're saying if it's that, if they specifically have free, under free new, we're going to sort the values for corruption ascending in one of the top 15. So we're selecting information based on logical operator. If it is exact, for rows that have exactly free under free new, we're going to sort the values of corruption, and then we want the 15. So I'm going to go ahead and run that. And now we have, based on this, the top 15 countries based on corruption. We can also create a subset of the data set if conditions are met. So rather than the chaining here, we can say, okay, let's say I just wanted countries where they are not free. And I'll put that as mask. So if I run this, I'm creating a mask and I'm saying, okay, give me that data set with just those, so just 49 rows. I can also create a mask too, where if data literacy is greater than 99, and then I have a row of 13 with there as well. So that's a good quick way to then set up conditional statements. We can use equals equals, less than, greater than, or we also have not equals to. So not equals would be, we did exclamation point here. So I'm going to overwrite that. And now we have those who do not have not free. So everything else. That's a quick way you can do that. We can also do things like set up a query. So I'll run a query based on our DF object, and I want to look at when country equals China. So I do that's going to pull up that specific, it's on a query, and then we get that specific row information. So before I'd mentioned how corruption is reverse coded. So higher corruption scores reflect less perceived corruption. I don't like that. I'm an experimental psychologist. I like higher scores to mean higher scores of that construct. So what we're going to do is we're going to flip this around. So we're going to reverse this. So higher scores actually reflect higher perceived corruption. Say there's a new variable called corrupt2. So corrupt2 is not in our data set yet. So I'm going to say corrupt2, give me a new variable in the df object, equals 10 minus each country's current corruption score. So now if I go ahead and then pull up the data frame, let me just move this down a little bit. Okay. Now we have our corrupt 2. First one's, so corrupt 2 7.5. The initial one was 2.5. So I'm together, they should equal 10. And that to always kind of give it a quick spot check. Great. So that's one thing we can do. The next thing is sometimes you might want to turn a continuous variable into a categorical variable like low, medium, and high, or discretize a variable. So we can do that by creating a function called def. Or not function called def, but we're going to create a function using the def here. When the function name is called categ. And what we're going to do is, if the series is less than 3.4, it's going to be low. If or else 3.4 equals 2, or if it's between 3.4 but less than 6.7, return medium. If it's greater than or equal to 6.7 but less than 10.1, return high. So I'm going to go through and apply this function and create a corruption categorized. Now, a quick word of caution. Let's say that we have our 0 to 10 for our corruption score. And we have all of here. If we go ahead and create these bins, we're treating all the cases with them from here, here, here. We're treating all this the same. Even though we might have one right here and right here, they're really close to another. But we're saying, nope, they're closer to everyone else in this bin than right here. So actually you lose variance when you do this. So I do want to mention just a word of caution. Let me go ahead and just erase this. Oops. So it can help with interpretations, but there is a cost associated. So just make sure you won't pay that cost. So what we have here is we have our function, or we've used by def. We've created, it's called categ. And now we're going to go ahead and say, we're going to apply for df corruption to a variable. We're going to apply categ here because series is going to be superimposed into this. Let's say if corrupt2 is less than. So wherever it says series, it's going to go ahead and port that variable in there. We're creating this new variable called corruption categ. We're going to go ahead and then apply a method for value counts. Oops, and I just realized I've got to get rid of the annotation. Let me get rid of that so it's not in the way. Okay. And value counts, key error. Okay, so the error, so what I did to fix that was I went ahead and just took this. Oops, making sure it is not highlighting the DF. Okay, there we go. So I'm just going to go ahead and highlight this whole thing. So we have our function in there. If I scroll down. Okay, now I'm going to go ahead and apply this. Corruption 2, so now we have 15. I'm going to go ahead and give it a quick visual just to make sure. All right, so high, no. And we can say, okay, for corruption 7.5, if looking at our code here, since it was between 6.7 but less than 10.1, high, that looks great. Perfect. So I'm going to go ahead now and use the value counts. And now we have our counts for each corruption categorized. We can then also get our descriptive statistics. So I'm going to get the mean. So use the mean function on df, specifically corruption 2. Now, because of this, we have missing. So because of that, we need to drop cases that have missing. So I'm going to use the drop NA, and I'm going to subset GDPPC and corruption 2 called dfcomp. And I'm storing, dropping NA and saving this as a new data frame. So now we have df and dfcomplete. Dfcomplete has no missing in two of these variables. So then I can run mean corruption 2. I get the mean for GDPPC. I can also do the same thing for median. Get the median for both of those. I can also get the standard deviation for both variables, as well as the variance. We can also use SP skew and get the skewness for each variable. That's not too bad. And kurtosis, a little kurtotic, but it's not too bad. We can also use the describe method on both of those variables, which gives us the mean standard deviation minimum, quartiles, and the maximum. So it's another quick way of doing this. Now, let's say we wanted to look at a t-test to compare two groups and see are those two groups statistically significantly different from one another if we were to look at um, differences within it. So first thing we need to do is so we're going to actually see, does GGPPC differ based on the corruption categories we used earlier? So we're going to be subsetting the data into three different categories and saving them into separate data frames. So a t-test is the most basic way to compare groups based on the scores of a single variable. Well, we divide corruption into three groups, we can only compare two of those groups at a time using a t-test. If you want to compare all three, you use an ANOVA, one-way ANOVA. So we're going to actually subset the data saying if from the complete data set, corruption category equals low, store that as a data frame called low corrupt. Do the same thing for medium and same thing for high. So now we have our different versions of here. First thing we need to do is we need to check for the assumption that the variability in GDPPC for the low group and the median groups are not statistically significantly different from one another. This is called test of homogeneity of variances, or Levene's test. If the p-value is less than 0.05, then we need to use a correction for the t-test to account for this violation. So this is where we don't want statistical significance. So when you use the Levene method on this from DSP, we're going to store that as Levene, and then we're going to go to print it out. And based on this, it is not statistically significant, so we're good. So now we can run a t-test. So I'm going to use t-test, and then I'm going to say low corruption versus high corruption for our GDPPC. And equal variances equals true. If we change this to false, then it's going to be due to false for equal variances. Or we use false for equal variances due to unequal sample sizes. So I'm going to go ahead and do this. And now we can then go ahead and, so if we want to use that corruption for non-equal variances, we can do that. So here we have statistical significance. We can also then calculate degrees of freedom. So let's say that equal variances was not true. Here we would change this to false if we did not meet that assumption. Okay, so if we but because of this, we also need to calculate degrees of freedom. With this update here, we do have it now, so this is kind of a moot point, but I'm going to show you how we can extract that. So we're going to take the length of how many cases we have in our low group, how many we have in our high, and then we take add them together and minus the two groups, and that gives us degrees of freedom, 72, which matches here. Great. So we can also then do a scatter plot. We're going to actually pick up this one in video 3. So I'll see you in the next video.